So just to get a sense of how many data scientists are in here, like if you can raise hands. Okay, not that many. What are the data engineers then? Okay, interesting. So that's fine, because I'm not going to go too much deep into data science. I'm mostly going to talk about data engineering and pipelines. So I'm going to talk about building a pipeline at scale and briefly brush over what systems you can use and how you should be thinking and problems that you should avoid when building a pipeline. So, so my name is Iason Bakogiannis and I work at Yieldify. And what is Yieldify? Yieldify, our tagline is conversion, smart and simple. So basically our technology goes on clients' websites and produces conversions. So we have overlays that go across devices and they have different messages giving discounts that effectively make people buy more products. So we're generating revenue. So the smart bit is about, because we have our technology on clients' website, we can collect a lot of information about the user's behavior, about what they're seeing, about the pages that they are on, the products that they're looking at, what they're adding to the basket, and we can use that information to drive more conversions from our clients. And the simple is because our technology is very easy to integrate. All it takes is to put a JavaScript tag on the website, and that's as much integration as you need for it to work. These are some of the clients that we have, like Marks and Spencer, Ben Sermark, Monarch, Friends Connection, and here's a few numbers. So we have more than 1.5 million impressions or overlays is when you display to a user a message that they might be interested in overlay to click and buy a product. Our servers receive over 5 billion requests per month. We're serving more than 40 terabytes of assets. That's all the images that make up an overlay. And we drive more than 1.6 million sales per month. So now when we're talking about data pipelines, sort of times we're referring to the systems. But what I like to think about it is about data integration, which is having the systems in place and making all the data that an organization has available to all of its services and people that want to use them. It's a very difficult task, and it increases in complexity with the amount of integrations that you have with different teams consuming the data. And here I have the data integration pyramid. So this pyramid shows how you go about by starting from capturing all relevant data. So as a business, generally you must try to capture all the data that you can and keep backups of them, even though you're not using them yet. So then try to work on a unified data model, just to have a common format, more or less, of how you're thinking about data, how you can combine data from different resources, and so that you can make it more easily available to your teams and systems. Then you have to put in place your processing infrastructure and the systems that you will have here, like MapReduce, Spark, data warehouses like Redshift, anything that you can think of. It could be even SQL databases. And then you have the data processing part, where then you have the kind of final of expression where you can run predictions, you can run analytics for your clients, typical reports, and even interesting visualizations. So when we first start talking about data pipelines, there's like the most elements that are closer to the source are events and logs. And an event is a byproduct of a user's interaction with a website. It means every time you are on a website and you either hover over something or you click on something, that generates an event somewhere, and another server somewhere captures that event and logs it. And the log is the simplest possible storage abstraction that it used to capture an event on a file. I like really this quote, like Netflix is a log generating company that also happens to stream movies. And most companies are kind of becoming like that because they have massive pipelines that consume data about every interaction that their users are doing. They basically become log generating companies that then try to build products on top of it. And you've seen like lots of companies diversifying their products because of that log generation. They come up with new interesting products. Here I just have an image of a typical log, how it like an event in a log. So every time a user will do something, you'll get a typical log, which is sometimes tab separated with dates, times, IPs, URLs, a huge query string with data about you guys, and that's it. That's how it looks. So what type of events do we collect at Yieldify? So typical events that are generated from the user's interaction is impressions. That's when we show an overlay. Then we also capture when a user would click on an overlay, when it's going to close an overlay, any sales that are generated from our technology, any form submit that the user will fail to get a coupon for a discount, and page views, so which pages they're on while they're browsing on the client's website. Another interesting thing that we're doing is we're collecting errors. And what I mean by errors is because a lot of our technology is linked to CSS selectors to signify specific events, for example, like an add to basket function or something that is trickier. It's trickier to set up and not so straightforward as showing an impression. That might be misconfigured, so we capture that as well and monitor it so we can alert our clients that something is not properly set up. So now I'm going to talk about the standard pipeline parts. There's more parts and there's more coming out every day as the ecosystem of pipelines becomes busier with real-time frameworks, more frameworks, Docker coming into play. But more or less the standardized pipeline parts is usually you're going to have some type of tracker. There are going to be event collectors, enrichment happening at some point. It could be on its own, but it could be part of the ETL or an analytics layer. Does everyone know what ETL stands for? Extract, transform, and load. So it's basically every process that we have data in some format, we have to apply some transformation. Maybe it's just filtering out some fields, or maybe it's generating completely new data and then loading into another data source. It can be again file, it could be another database, it could be another framework. So now I'm going to give you a little bit more detail of what are trackers and all the other standardized parts. So when you want to start tracking activities, you usually set up an image pixel or a JavaScript tag. The only difference is the tag description. JavaScript tags are, sorry, when I said difference, it means the way you deploy it on a website. JavaScript tags they allow way more flexibility to what you can do with them. So if you put a tag on a website, you can capture how much time a user hovers over something, how far down they've scrolled down the page, any type of operation you can do with JavaScript. While when you have a simple image pixel, you usually get notified about things, the time that this user is on that URL and what browser they're using, so on. Typical trackers that you're going to find are collecting information, Google Analytics, Yieldify, and some websites. Lots of trackers from ad exchanges because they're trying to bid for you for a placement and show you an ad. And lots of browser extensions actually have trackers embedded in them, transmitting the fact that you're on a page. So data collectors. So data collectors, usually they receive data from GET requests. They're just an array of servers that their main functionality is to log those events to a file. Simpler systems follow more batch. They do a log rotation every half an hour, every an hour, and they move them to a cloud storage like S3. The fields are usually a unique user ID, a timestamp, a user agent string, and IP. But you can also pass extra context by information you have about the user or user's interaction with your technology on a website. Also, you can have more kind of advanced collectors now that the technology exists that are pushing to queues or message brokers so you can consume that information in real time and act on it as well. So if you can capture the event that the user is clicking, has clicked, for example, 3 times on this website, on those 3 products that are of the same category, maybe you can offer them a bigger discount. So real-time systems enable you to do that.
To the context.
The context is actually...
How to filter it.
Excuse me?
How to filter it.
How?
How to filter
The context, how to filter. No, so when I'm talking about context, it's something that we specifically assign to the event. So it's not, we're not inferring context of the event. It refers to the fact that you have standard fields at any GET request that you send, but then which are basically IP and the user's cookie and the timestamp, for example. And this is kind of what you get from most data integrations. Excuse me?
It's so far, but in addition to user time and IP,
yeah.
what context are you going to choose it?
So the context is just something that okay, I'll give you an example. Let's say that you capture an event of a sale, right? So a context of a sale would be, so you have the standard basic fields, which is that this is the user ID that bought a product. He bought it on this product page. And then the sale was $80, and it was that product ID, and it was from that client ID. And so you can add lots of useful information apart from the basic information. Okay. Then typical enrichment processes is convert IP to longitude, latitude, and country and city. Again, you would use this to either report on the distribution of your population on your sales back to the client, but you could use it also for targeting systems. Let's say that you want to target only people that live in London. So because you won't have that information, by having an enrichment layer that either in batch or in real time transforms that information, it makes it available for users like with minor delay if you have a layer like that. And the same applies for user agent string conversions, because in the request you get the user agent string. You might again want to target specific device types like mobiles and a specific operating system, depending what your algorithm as well wants to do. And last, you might want a layer like that to add specific data, because you might not be able to get that from the browser, but still you want that data to be available to your ETL process before it starts processing. For example, it could be related to your data model about clients and websites and campaigns. That will make life way easier. Rather than doing all those complicated joins in the ETL layer, you do it upstream. So here I'm kind of a brief explanation of the storage and processing system. I haven't separated them because they sit very closely. Usually you would read and then write directly from one system to the other, and they're going to be situated very near. So you'll have a storage solution like HDFS, S3, Google File System, then something to process the data like MapReduce or now Spark, and Redshift, which kind of sits in between, which is a data warehouse. And usually you'll have duplication, some duplication of your data across these data sources. So here I have a kind of reference architecture from Pinterest that displays a typical pipeline. So here we can say the browser is generating events which goes to the app layer, which is the collection layer. The data go then to Kafka, which is like a message broker, which the good thing about that is it gives you a level of security because it can maintain data for some time if something goes bad, but also it allows you to consume events in real time. So if you want an application again for visualization or for targeting, you can consume Kafka. Pinterest actually has written also their technology called C-Core, which allows to batch messages that are in the queue and push them to S3 just for safekeeping. And if you want to do ETL, it's easier to do it off of flat files, like with Spark. And they also use, they have here a prototype, I guess it's Spark streaming. So in real time, they use the streaming application of Spark to push data into a NoSQL database and produce insights in real time. So I'm going to show you now Yieldify's architecture. So what you see up there is the browser, which has a JavaScript tag. Attached to that is a tracker that basically bundles up the events and their context in a way we have set, and then transmits it to a data collector layer, which is in auto-scaling groups, so it can absorb all the traffic and withstand any traffic spikes that we have. Those are pushed then to a Kinesis. It's very similar to Kafka. Actually, I think it was greatly influenced by Kafka. Then we have a real-time enrichment layer. From the real-time enrichment layer is going back to Kinesis. And from Kinesis is going to the processing and storage kind of layer, which has these three elements, which is S3, Redshift, and EMR. There's also a black kind of AZ there. That stands for Azkaban, which it's a job scheduler. If you're not using one and you have lots of MapReduce jobs or transfer jobs, it's very good because you can have dependencies between jobs that run on the cloud, and we can also redo, and it has timeouts. So it's the heartbeat of the big data jobs between EMR, Redshift, and S3. Oh, sorry. And here are the technologies that the different parts are written. So the tag and the tracker are written in TypeScript. The data collection, to be as fast as possible, is in Go. The enrichment layer is in Python. And then we have also for the EMR, we do Spark. And we also use Looker to visualize and allow also the more commercial teams to run their own queries. Okay, so we've got ourselves a pipeline. So what are we doing with that? So we do a lot of processing with Spark, which is we're using Python. Usually we've created our own Docker images so we can test our scripts and develop locally. And once that's done, we deploy on EMR. We have been prototyping various applications with MLlib. So some of the areas that we're doing work right now is a profile service that keeps for users a history of their location, frequency of their visits on a website, purchase history on a website, devices that they're accessing from, and also we're working on intent to purchase and interested in different product categories. We're also modeling products, so we're creating a product graph. We consume product feeds that are in XML and CSV. We also get some information from scraping. And so we have a representation of products to images and other similar products and reviews and descriptions. And we also model around websites. We do funnel mapping. This is an example of a specific vertical where we can keep the user journey between landing page, product page, checkout, basket, thank you page, and an industry benchmarking, which is how does your product perform versus the product page performance versus the vertical average, and standard analytics like page views and unique users. So some tips when you're about to build your data pipeline, if you're interested in building one, what to watch out for. So I included GIFs. So first thing, collect as much data as you can. What does that mean is when you're about to set up your tracker and you want to collect data, spend a little bit more time and don't drop unnecessary fields because you might not need them right now. So collect a little bit more than you initially thought you would need because it's easier to filter out unwanted data later on rather than not collecting them beforehand. And what I mean is, let's say that you figure out you have to go back and generate that extra field on your data, then you have to reprocess basically all your flat files to go back and add that field. Or if you realize that you have to go make some changes to your tracker to capture that extra field, then your tracker might be deployed on clients' websites, so it might not be so easy to go and change the tracker to add the extra information. So spend some extra time to figure out what information, and don't be concerned so much about storage space and if this field is going to be needed or not. So make sure your data collection scales. So be prepared to on your collection layer to receive traffic spikes, and sometimes you might not want to miss those events, especially if it's events that your revenue is dependent on it. So if you're measured on clicks on sales, maybe you can miss a few impressions, but you don't want to miss that 1 or 2 sales that prove your value to the client. Also, engineer your technology so it does not do harm to your client's website, so you don't want errors thrown and times out. But it really depends on your use case. You can tweak how many events can pile up or you can miss. Choose a data format and standardize fields. Usually the logs that you're going to be collecting in your log collection layer are going to be in TSV, which in the beginning is very fast, and most systems you can do split by TSV and load it, but it gets way difficult as those fields pile up for any reason. So there's lots of protocol and formats that you can take a look, so like Avro and proto buffers and even JSON. So when you are about to collect data, log into something more flexible than TSV. And also try to standardize common fields, especially if you're ingesting data from multiple different data sources. As I said before, most of data sources will definitely have a user ID, an IP, a browser URL. You can start standardizing the way these fields look in a format, and then maybe extending it with an optional or something that will be easier to consume once you reach your ETL layer. I don't know how many of you know where this is coming from. Okay. So this is about logging files in the same way to S3. So create a folder structure in S3 to store your data that really makes sense, even it's like very explicit. So add as much dates as you can, or campaign IDs or client IDs, and then even in the name of the file, add more data to indicate where that file refers to or what that file refers to. Rather than having pre-configured buckets and keys that will look weird. First, it becomes more human readable. It gets easier to reason which bucket you have to pull in to your process. And it is easier to recover in case of something goes bad. So you can regenerate data from that specific key range, or you can easily recover if you have a copy process from an S3 to Redshift. You know where your data sits more or less. So very important. And don't overdo it with managed services. I don't know how many of you have like lots of data on S3 and have toyed around with Glacier or other services. So at some point, data becomes expensive because you're collecting data over years, and then you run your machine learning and you produce more data output, and at some point you say, okay, I have to cut costs. You look at your Amazon bill, and then you're thinking, okay, I don't want to throw away my, my data, so what's the cheaper solution? Maybe it's Glacier or another service. So once you reach there, just read the instructions, because it might not be so easy or so cheap to pull out data from Glacier as you thought. So yeah. So and then there's again lots of ways, lots of places you can have your data. So keep an eye and try to figure out what's the best place to keep it. So personally, I like S3, but don't overdo with how much you store.